Are you serious? Where's my notes? All right, so 2.2 is on weighted averages. So now if you're just talking about your regular average, taking the regular average, you add up all your data values, divide by the number of data values. And most people, have done that before. You just add your data values up and then divide by the number of data values. So if I have the data set 1, 2, 3, 4, 5, then to find the average, I add up those values. 1 plus 2 plus 3 plus 4 plus 5 will give you 15. The number of data values I have is 5. So divide by 5. That means the average is 3. All right. So the difference between this, just taking the regular average, and actually taking the weighted average is that certain values will show up more than once, and you would account for that versus trying to add them up singularly. Or certain values will have more, like I said, weight to it, and you want to give an account for that. So you'll see an example of that in a second. Just giving everybody a chance to write down the problem or write down anything. Let's go to the share. So this is your first problem out of 2.2. Is going to walk you through calculating the weighted average. So if you see in the, well, let's look at it. It says, a survey asks students how many children are in their household. Complete the table to compute the average number of children per household. So frequency is how many times the result occurred. So when we look at this chart, 3 people or 3 families said that 0 children are in their homes. 7 families said that one child is in the home. 10 families said 2 children are in the home. 3 families said 3 children are in the home. 3 said 4 children are in the home. And then 2 said that 5 children are in the home. So the frequency lets you know how many times that result or that number occurred. All right. And product is just, as far as math is concerned, is multiplication. So when you look at this first answer that they want from you, 0 times 3 is 0. Hold on 1 second. So that's going to be 0. Next one, 1 times 7 is 7. 2 times 10 is 20. 3 times 3 is 9. 4 times 3 is 12. And then 5 times 2 is 10. So the first step is to multiply your data value times the number of times that data value occurs. So that's what product means. Product is multiplication. Any questions? All right. So the next one, at bottom row, says sum. Sum is addition. So we're adding up all the data values that we have in those columns. So the frequency, add up the numbers that we have in the frequency. 3, 7 is 10, 10, 20, 26, 28. And then here, that is 22, 42, 51, let's see, 58. So all you did was add up those columns together.
So for the, excuse me, for the frequency, we're just copying them numbers over into the column, because I thought the frequency was how many times that was recorded, because 10 was only recorded once and 3 was recorded 3 times. That's not what frequency mean?
Yeah, 10 was recorded twice and 7 was recorded once. Like if you go back to the original, all they did was transport what was over there in the original over here to the right. So 0 was recorded 3 times, 1 was recorded 7 times, 2 was recorded 10 times, 3 was 3, 4 was recorded 3 times, and 5 was recorded 2 times. Or it appeared, that many times, as far as the people's responses were concerned.
Right, but that's not what's in the. Maybe I'm not saying it. Okay.
So no, I'm saying no. Talk to me because your issue may be someone else's issue that's not saying anything. So what is it that you're not that you're seeing that you're confused about?
Because that's not what it looks like is written in the frequency column. The frequency column, like exactly what is in what was in the original column. Like it doesn't look like it's communicated as how many times it shows up. It just looks like it's copied what was to the left.
Yeah.
Am I
We
not
didn't.
seeing it right?
Yeah, no, that's right. We didn't change anything. They gave us those data values. Children, the columns of children and frequency were given.
Okay.
Yeah. That's nothing that we changed. That's not going to change. They already recorded that. So in other words, there was a survey, and they asked They asked 28 different people. How many children did you have in your home? So the frequency, which is 3 for the first one, 3 people said that they have 0 children in their home. So and then 7 people said that they have 1 child in the home. 10 people said they had 2 children in the home, and so on. So those 2 columns doesn't change when we go to actually filling out the chart. Is that straight? That's cool. I don't know if your face is cool. I think you're throwing the thumbs up because you do. It's not straight. So
It's
okay.
no. Maybe I thought that grid was blank before we started. I don't know what I was looking at.
Oh, no. The only thing that was blank was the product column.
Okay, maybe that's where I lost
Hmm.
myself. I don't know what I
Okay,
was looking at. I'm
gotcha.
sorry.
Oh
Continue.
no, you're fine. You're fine. So to get that product column, all we did was multiply the children times the frequency, and that's how we got those different. That's the only thing that we did. And then at the bottom row, the sum was blank. So now we adding up all the frequencies, and then we adding up all the product results, and so we have 28 and 58. All right. And then, the average number of children per household, the way you would find that is you would take the product sum and divide by the frequency sum. And it said they want as an integer or simplified fraction. So if I go back to my screen, you share. How's this not going down? All right, here we go. So I'll just erase this one. So that'd be 58 over 28. And we want to reduce it down as much as possible. That's 2 times 29, 2 times 14. 2's cancel, leaving me with 29 over 14. And that should be my answer. So let's go back. Yeah. So before we leave that problem, we'll try another one, questions. So we'll do one more. There are only 4 problems in this section, in this homework. So I'm trying not to do all your homework, of course. So I'll do one more. And then if you have any issues with anything else that you try, always feel free to ask. All right. So the next one is how your grades are calculated. Your GPA is a weighted average. Your grades are weighted by the credits for each course. Quality points are the product of the credits for the course on a 4.0 scale, 4.0 scale. So we're going to do the same thing that we did before. Like I said, that first problem was just walking you through the steps of how you would calculate the weighted average. So here we have 4 credits, and a C is worth 2 points. So that's 4 times 2, which is 8. Then we have 3 credits, but a B minus is 2.67. So 2.67 times 3, 801, 8.01. And then A minus is 3.67, and that's a 4 credit class. So 4 times 3.67, 14.68. All right, questions on that before we look at B? All right, so let me go. So now what we're going to do is what we did in the last one. Notice this one doesn't tell you exactly what to do because they feel like they told you in the last problem what you should be doing. We're going to add up our quality points. We're going to add up our credits and then divide with those numbers. So my quality points, we had 8 plus 8.01 plus 14.68. Sorry about that, drop my pen. So we have 8 plus 8.01 plus 6.8. That should be 30.69. And then we had for our credits, I think it's the same thing from my last class. Yeah, we have 4, 4, and 3, so that's 11. So we take that 30.69 divided by 11. $2.79. All right. Questions? Any questions on the process? All right. I'm sorry. Was my screen shared? I don't know if my notes were shared or not. Right. But just in case, I thought it was. I'm not sure. So, like I said, we did 8 plus 8.01 plus 14.68. That's my quality points. They give me 30.69. Credits was 4, 4, and 3. That adds up to 11. Then divided that 30.69 by 11, I got 2.79. So Sharon, that should be, and always pay attention to your directions. They want us to do our decimal to the hundredths place, so we're good to go. 2.79, and that's the answer. So before we leave this section, questions. Make sure we're all right. All right. So 2.3 is proportionality. All right. So direct proportion is when one value increases, the other increases as well. Inverse proportion is when one value increases, the other decreases. All right. If I go too quickly, let me know. So what's going to happen is that we're going to have keywords that's going to dictate what formula, what relationship we'll use. Direct proportion is when y is directly, you'll see it in the phrasing, in your wording, and you'll see when we get to the problem. It says y directly is directly proportional to x, or y varies directly as x. The way we will set up the problem is y is equal to kx. K is our constant of variation, or you may see the phrase constant of proportionality. So K will always be a part of these relationships that we're going to create. All right. Inverse proportion. Key phrasing here is y is inversely proportional to x, or y varies inversely as x. And so instead of y equal to k times x, we'll do y equal to k over x. All right. So let's go. Don't copy down that yet. Let's go to the homework first. All right, so the first one is just getting you used to the concept of establishing something being inversely proportional versus something being directly proportional, or not being proportional at all in reference to this assignment. So remember, directly proportional, or something being directly proportional to something else, means that when one increases, the other one increases. If it's inversely proportional, when one increases, the other one decreases. All right, so for each pair of quantities, identify if they are directly, inversely, or not proportional. So we'll do a few of these. First one, tax charged for buying an item, cost of the item. So as the cost increases, the tax increases. So that means they are directly proportional. So it's not a situation wherein as the cost increases, the tax decreases. So both of them increase with each other, so that's directly proportional. Next one, population of a region and the area of a region. So they're not proportional, because no matter how many people you put in Chesapeake or how many people you put in Virginia Beach will not increase its territory because you put more people into it. So they are not proportional to each other. There's no relationship. All right. Next one, average speed to work, the time it takes. So as your speed increases, the time it takes to get somewhere decreases. So that means they are inversely proportional. All right. Questions on what number one is about. Basically, like I said, it's trying to establish, make sure you okay with the concept of what it means to be inversely proportional versus directly proportional, or not being proportional at all. All right, let's look at the next one. Number of miles driven is proportional to the gas the car uses. Note that driving is assumed to be constant over time. So for two proportional quantities, the decimal equivalent of the fractional representation of their ratio. So that goes back to K, our constant of proportionality. So that number is going to be constant. It's going to be a fractional representation of their ratio, and it's going to be constant throughout all of the problem. So that's going to be a constant of proportionality. Here we have assumed that a person drives 125 miles on 5 gallons of gas. Find both constants of proportionality. Express the first as a whole number, second as a fraction. So what they want here is the first one. I'll go ahead and go to the notes. So it's the number of miles driven is proportional to the gas the car uses. Gas car uses, yeah. All right. So this is a direct proportion because the more miles you drive, the more gas you need, or the more gas you will use. So in this case, if we wanted to call it Y miles driven, X is the gas the car uses. It's a direct proportion. So in my last class, I had 125. This time we got 120. I had 135. This time we had 125. So they want us to write both constants of proportionality. So the first one is just taking that 125 miles on 5 gallons of gas. Just do 125 divided by 5, and that's 25. And so, like I said, if we go back to the problem, when I go to set it up, I will put this 25 in for k. That will be y equal to 25x. So now, if I were to solve this for x, so the first answer, let's go back to your share screen. So 125 divided by 5 is 25. So that's the first answer they're looking for. The next constant of proportionality expressed as a fraction is to solve this equation for x. So I would divide both sides by 25. 25's cancel. And that's 1/25 y equal to x. So this 1/25 is the other proportion of constant of proportionality. So it's just going to be the inverse of whatever number you put in the first one. So let's go back. So that should be 1 divided by 25. So whatever number you put here, the first number you put as b, the inverse will be the other one. So in other words, let's say if you had 3/4 for that first number, the other constant of proportionality would be 4/3. You're just flipping your fraction. All right. Questions on that one? All right, give you guys a chance to write this one down. This is the next problem we're going to try. It says a recipe for 16 banana nut muffins. Let me erase all my scribble. A recipe for 16 banana nut muffins calls for 1 cup of flour. The number of muffins that can be made varies directly with the amount of flour used. There are 2.5 cups of flour. How many muffins can be made? All right, so let's look at the steps. So these steps you'll be able to follow no matter whether you're dealing with direct variation or direct proportion or inverse. It doesn't matter which one you have. If you follow these steps, you will be able to solve the problem. And before we get started, also, yes, there is another way of doing these. I'm just teaching it according to what they have in this section. But yep, there is another way you can set up your proportions, but just going off the setup that they have in this section. So first you want to establish which relationship you're going to use. And your key phrase here is varies directly. So that means you're going to use y equal to kx, that type of relationship. All right. Remember, if it said varies inversely, you would do y equal to k over x. All right, next you're going to establish what variables to use. Last time I used N and A. This time I'm going to use M for muffins, F for flour used. Doesn't matter. You could leave it as X and Y, but you do want to make sure you establish what X means and what Y means. And so that's what we're doing here. Establish your variables. I'm letting M represent the number of muffins that can be made, and F is going to represent the amount of flour used. All right. So now we're going to rewrite the relationship with the established variables. So we're using direct variation. So also, which I mentioned in this last class, um, you don't want to use K as one of your variables because remember, K is going to be a part of all of your relationships because that's your constant of variation. So this is going to be M K times F. M equals to K times F. All right. And remember, this goes back, and I didn't emphasize this part. Let me go back. It varies directly. That's your key phrase. What comes before that is going to be your first letter. So the number of muffins that are made that goes in front of your equal sign varies directly. Whatever comes after varies directly goes behind your K. And so that's the number of, or the amount of flour used. So that's how we set this up. The number of muffins that can be made, that's going to be our M. F is the amount of flour used. So M comes before the equal sign. That's what came before varies directly. And then F becomes after your K because that's what came after your varies directly. All right, questions, questions, questions. All right, so you want to establish your given information. So the first one, they gave us number of muffins made is 16. The amount of flour used is 1 cup. Then they ask us how many muffins can be made if you have 2.5. If you have 2.5 cups of flour. All right. So now we can find K. That's our constant of proportion. And we have F. So we plug in the information that we have completed. In other words, the one that has both M and F involved. And we plug that in to help us to find K. So remember our relationship is M equal to K times F. So I plug in F, which is 1, plug in 16 for M. All right, so k times 1 is easy for us. That's just k. And we have left 16. All right, so I can insert k now into the relationship. And let me erase the n and m and f, n and a, excuse me. And so that's going to be m equal to 16f. Question before we look to finish this off. That 16, like I said, that 16 that you solve for k is going to be constant throughout all of the problem. So you can keep that in there. Now we can use the given information from the next relationship to find the missing piece. So we have m equal to 16f. They give us the second f, and we can use that to find the second m. So 16 times 2.5 is 40. So 40 muffins can be made if I have 2.5 cups of flour. Questions, questions, questions. All right. So next one. So this next one didn't ask us to solve the problem. It says the distance d, and they wrote it weird. It says the distance d, and it said you bike. I don't know what, I think they left out a lot of words here, but it says the distance your bike, you ride your bike. That's what I was thinking they were trying to say. The distance you ride your bike varies directly with the amount of time on your bike. I don't know. It just they left out some words. I just put your, and your didn't even make sense. They had you and you, and it says suppose you bike 9.6 miles. So I'm assuming. So suppose you ride your bike 9.6 miles in 1.25 hours. What is an equation that relates to d and t? So they give you the variables this time. They're calling d distance and t time. And they said that it varies directly. All right. So if that's the case, if we want to just write the equation, then we know they already told us this directly. That means it's going to be d equal to k times t. Because remember, whatever comes before the phrasing varies directly is the one that comes first in your equation, and then whatever comes afterward comes after the t. So that's what we have here. And 9.6 is d, 1.25 is t, so I'll plug them in accordingly. Solve for k by dividing by 1.25 on both sides. K is equal to 7.68. And so now plug k into the relationship. That's going to be d equal to 7.68 t. So this is all they ask of you in this problem. So you would look for that relationship, click A, B, C, or D. Then they ask you to graph it. So all you do is make sure you have a graphing tool that you can use or rely on. If you don't know how to use it, make sure you get with me. You can always type in Google graphing calculator. They have them in there, stuff like that. So don't forget in this type of situation. As a matter of fact, I'll do this first. And they'll show you that D is on vertical, T is your horizontal. So that means D is Y, and then T is X. So All right, so let me go back to the share. All right, so this one has different numbers, so I'm just picking anything just to go ahead and get to the other part so I can show you something. Oh, got that one right. All right, so with the graph, notice also on the grid, if you're going to graph, make sure you are using the grid tick marks that they give you. Notice down bottom is from 0 to 5. On top is from 0 to 30. So they're giving you what type of scale to use on your grid when you go to graph so that you will be able to see the graph the way they are showing it right there. So once again, your horizontal axis is going from 0 to 5. Your vertical is going from 0 to 30. All right. So I just guessed there. But yeah, you should have a graph that would graphing tool that can show you that. All right, questions so far. Trying to see if there anything if an equation that meets the proper varies inversely. So we could do one more. Just trying to find a good one. All right. I have a ton of questions, but I don't want to go content. All right. Well, has someone that had questions? If you want to ask, feel free. If not, then you can always shoot me email. We can do it, set up a Zoom or something like that. But this is your time. Asking a question now may be beneficial to someone else as well. So feel free to ask. But if not, I understand. Yep. Class time is for questions, so I don't have a problem with it. As a matter of fact, the only reason I'm doing this extra one, notice, man, last class we didn't even get to an extra one because they had questions. So yeah, this is you guys' time. I don't mind answering questions if you have them. All right, so find an equation that meets the conditions. P varies inversely as D. Just make sure I wrote it right. Oh, P varies inversely as D, and P5D is equal to 4. Okay, so we know inversely is our keyword here, varies inversely. Excuse me. P varies inversely as D. So the first thing we do is set up our relationship accordingly. Remember, inversely means I would have K over the variable given. So P comes before varies inversely. So P comes before the equal sign. Then since it's inversely, it's K over the next variable, which is D. If it was directly, just to note, it would be K equal to K times D, P equal to K times D, if it was directly. All right. So we just want to find the equation. So what we need to do is find K. P is equal to 5. D is equal to 4. So I plug those values in accordingly. So now multiply both sides by 4 because I want to solve for K. Fours cancel on the right. On the left, I have 4 times 5, which is 20. So now I take that 20 and put it back into our original relationship with P equal to K over D. That's going to be 20 over D. And that's our answer. Questions on that? Also, make sure that if your letters are capitalized, they stay capitalized. If they're lowercase, they stay lowercase. Because it will mark it wrong if you were to put capital D when they were expecting lowercase d and vice versa and all this stuff like that. So make sure you use the letters that they introduce to you. All right. Questions, concerns, comments on anything? So that's it for right now. Like I said, I don't want to do all of your homework, but I do want to get you guys started, get you guys flowing and going. Make sure you try the stuff out. See if you have any problems or issues with any of them. And you can always feel free to ask them during class or shoot me an email. Outside of that, that is 2-2 and 2-3. And like I said, there may be some things in there. I didn't go through all of the homework all the way to the end because, like I said, I didn't want to do it all. But so there may be some things in there that you want to see done. But I try to reserve that for your, for you to go in there and then bring it to me versus me just showing you all of your assignments. So, like I said, make sure you get in there, try the stuff out, see if you get stuck. If you're having questions about Zoom, not Zoom, but Excel, or having issues with it, people have been setting up separate times to meet up with me so they can ask their questions. Make sure you do that as well. I know some people sent me some emails last night, so I'll get to those today if you did that. So just give me a chance to get to them. Outside of that, you guys have a good day, and I will see you on next class.